Okay, so here we have two vectors, a and b, and there is going to exist some angle between them. Here we have called it theta. Now, if we want to find this angle, what we can start by doing is drawing another vector that connects the endpoints of these two vectors. Let's call it c. And now we can see that these three vectors make up a triangle where the side lengths are just the magnitudes of the three vectors. And so we can find the angle by using the cosine rule. So the cosine rule gives us that the magnitude of c squared is equal to the magnitude of a squared plus the magnitude of b squared minus 2 times the magnitude of a times the magnitude of b times cos theta. So we can rearrange this to get that cos theta is equal to the magnitude of a squared plus the magnitude of b squared minus the magnitude of c squared divided by 2 times the magnitude of a times the magnitude of b. Okay, so if we consider the case that a and b are two-dimensional vectors, then let's say that a is equal to a1, a2, and b is equal to b1, b2. Now, from here, we can see that c is equal to b minus a, and so is equal to b1 minus a1 and b2 minus a2. So we can find the magnitudes of these vectors by using Pythagoras' theorem. So we get that the magnitude of a squared is equal to a1 squared plus a2 squared. The magnitude of b squared is equal to b1 squared plus b2 squared. And the magnitude of c squared is equal to b1 minus a1 squared plus b2 minus a2 squared. And if we expand this out, we get it's equal to b1 squared minus 2b1 a1 plus a1 squared plus b2 squared minus 2b2 a2 plus a2 squared. And now we see over here we are subtracting the magnitude of c squared from the magnitude of a squared plus the magnitude of b squared. So these b1 and b2 squared and a1 and a2 squareds are going to cancel out. And this is going to give us that cos theta is equal to 2 b1 a1 plus 2 b2 a2 divided by 2 times the magnitude of a times the magnitude of b. And these 2's, of course, are going to cancel out, giving us that cos theta is just equal to b1 a1 plus b2 a2 divided by the magnitude of a multiplied by the magnitude of b. And so this is how you would find the angle between two-dimensional vectors. We can generalize this for higher dimensional vectors. So if we say that a and b are n-dimensional vectors, such that a is equal to a1, a2, and then all the way down to an, and b is equal to b1, b2, all the way down to bn, then we get that the magnitude of a squared is equal to a1 squared plus a2 squared and then plus all the way to an squared. And the magnitude of b squared is equal to b1 squared plus b2 squared plus all the way to bn squared. And of course, the magnitude of c squared is going to equal b1 minus a1 squared plus b2 minus a2 squared plus all the way to bn minus an squared. Okay, so from our formula earlier, we have that cos theta is equal to the magnitude of a squared plus the magnitude of b squared minus the magnitude of c squared divided by 2 times the magnitude of a times the magnitude of b. And so from the numerator of this expression, we can see that the corresponding terms are just going to cancel out. So say for the ith element, we have that ai squared plus bi squared minus bi minus ai squared is equal to ai squared plus bi squared minus bi squared plus 2ai bi minus ai squared, which is just going to leave us with 2ai bi. Therefore, our formula is just going to become cos theta is equal to 2a1 b1 plus 2a2 b2 plus all the way to 2an bn over 2 times the magnitude of a times the magnitude of b. And these 2's, of course, are going to cancel out, which leaves us with cos theta is equal to a1 b1 plus a2 b2 plus, and all the way to an bn divided by the magnitude of a times the magnitude of b. So this is our general formula that we use to find the angle between two n-dimensional vectors a and b.